In this video, we're going to divide these two rational expressions. All right, so remember that division of rational expressions will be exactly like division of rational numbers or division of fractions. So I'm going to copy down the first rational expression. I'm going to change it to multiplication, and I'm multiplying now by the reciprocal. Sometimes the mnemonic device we use is copy.flip, but ultimately what's going to happen is the first rational expression comes down, I change my division to multiplication, and I multiply by the reciprocal. So I exchange the numerators and the denominators. Okay, so for multiplication now of rational expressions, what I'm going to do is just factor all of these polynomials completely and then see if there are any factors that are in common between the numerators and the denominators, which then I can cancel them. So it looks like in the first one I have a greatest common factor of x, so that'll leave me with x cubed plus 8. In the bottom here it looks like x plus 2 and x plus 2 is going to be how this quadratic factors. X squared minus 4 is the difference of squares, so x minus 2, x plus 2. And it looks like down here I also have a greatest common factor of x, which will give me x squared minus 2x plus 4. All right, I see that x cubed plus 8 is the sum of cubes. So let's go ahead and factor that as well. So I have the x, but sum of cubes means I need the cubed root of the first term and the cubed root of the second term, which x cubed goes to x and 8 goes to 2. And then my second set of parentheses is the square of the first one minus their product, so 2 times x, plus the square of the second one. Okay, so now let's just carry everything else down. Multiplication, and this quadratic here actually will not factor down anymore. This is an irreducible quadratic because there are no real numbers that will multiply to make 4 that add to make negative 2. So this guy just comes along for the ride. But you'll notice though immediately probably that x squared minus 2x plus 4, x squared minus 2x plus 4, these are the same. So I'm going to go ahead and factor those out. And remember, anything that exists in the numerator that also exists in the denominator, I can, cancel out. So here's an x plus 2 and an x plus 2. Here's an x plus 2 and another x plus 2. And then it looks like the x's here also cancel. Gosh, so all of that went away on the bottom, and almost everything in the numerator also went away. The only exception is the x minus 2. So it looks like my quotient is x minus 2. But let's take into consideration values that were canceled out, so values of x that we cannot use. Okay, so x plus 2 canceled out, and the x plus 2 here canceled out, but those are the same things, so I only need to consider him once. So x cannot equal negative 2. Also here I have the x that canceled out, so I know x cannot equal 0. And right here I have the x squared minus 2x plus 4. I already said that this is an irreducible quadratic. This will not factor over real numbers, which means there are no real values of x that I can plug in here that will give me a 0. So I do not need to take them into consideration because right now I don't care about complex values of x. Okay? In a previous example, also we have to go back to the top and we have to look and see that, hey, this original problem was a division problem. So even though this x squared minus 4 ended up in the numerator, he didn't start that way. So we need to take into consideration this denominator as well. So the x squared minus 4, remember, factored to x minus 2 and x plus 2, and those values cannot be 0. So x cannot be 2 and x cannot be negative 2. Well, one of those we had already picked up here, x cannot be negative 2. But we also know that x cannot be positive 2 because of the original expression. So how can I write this a little neater maybe? So the answer is x minus 2. That's the quotient. But we know x cannot equal plus or minus 2 or 0. So right there is the quotient of these two original rational expressions.